Hey Paige, so firstly what we're going to do is go through some expanding. Most expanding is pretty easy, but we'll have a look. So simple expanding, we use our rainbows. 2 times x is 2x, and 2 times -4 is -8. Second question, let's say -5x times 6x plus, let's say, 7. Again, we're going to use our rainbows. So -5x times by 6x gets us, well, negative. 5 6s are 30. X times x is x squared. Then our next one, negative times a positive is a negative. 5 7s are 35. And we have an x. Alright, so that's just simple expanding. And remember, when there's a negative out the front, that is going to change the sign in the middle. Alright, so now we're going to go to binomial expansion. So where we have two brackets times them by each other. So x plus 5 times x minus 3. So again, we're going to use our rainbows. It's going to be both terms in the first times both terms in the second. So firstly, x times x, x squared. X times -3 is -3x. 5 times x is positive 5x. And positive 5 times -3 is -15. Then we're going to collect the like terms, which are both our x's. So we've got x squared minus 3 plus 5 is positive 2x. Take away 15. Alright. Another one's maybe similar to that. Could be 3a minus 4, 4a minus 5. Pretty similar. Okay, 3a times 4a is 12a squared. 3a times -5 is -15a. -4 times 4a is -16a. And -4 times -5 is positive 20. Again, let's collect like terms. So 12a minus 15 minus 16 is minus 31a plus 20. Now, perfect square expanding, so we might have x plus 4 all squared. Now, slowly, all you can do with a square is just repeat the brackets twice and then do normal binomial expansion. So x times x, x squared. We have positive 4x. We have positive 4x. And we have positive 16. 4x plus 4x is 8x plus 16. Now, to do it quicker though, the rule for perfect square expansion is, if we had a plus b all squared, is you square the first, you square the last, and you double the product of the two. So the product of the two is positive ab, and you double it so you get 2ab. So if we go back to our question, we can square the first, x squared, square the last, 4 squared is 16, times the product, do the product, which is times, and you get 4x, double it, and you get 8x. Now it doesn't matter which way you go, but obviously that is the quicker way. So with another one, 2a minus 5 all squared, square the first, 2a squared, 2a all squared is 4a squared, negative 5 squared is positive 25. Times those two together and we get negative 10a. Double it, we get negative 20a. So these ones are obviously called perfect squares. So next up, when we have a binomial product with x minus 4, for example, and x plus 4, so we have exactly the same thing in both brackets except opposite signs, we can do slowly. X times x, x squared. X times positive 4 is positive 4x. Negative 4 times x is negative 4x. And negative 4 times positive 4 is negative 16. And when we collect like terms, positive 4 minus 4, they cancel each other out. And we're left with x squared minus 16. Now that is called a difference of two squares. So when we can recognize that this results in a difference of two squares, so for example 2x minus 5, 2x plus 5, so exactly the same except opposite sides, what we can do to make it quicker is square the first. So 2x squared is, all squared is 4x squared. Square the last, which is 25, and it must be a minus in between because it's the difference of two squares. So again, we'll do another one. 3y plus 4, 3y minus 4. Square the first, 9y squared. Square the second, 16, and a minus in between, because the rule states a minus b times a plus b gets us a squared minus b squared, or a difference of two squares. But again, you can do it slower. Alright, so now with factorising, much harder. Alright, we'll start off with simple factorising. Highest common factors. We must always look for that first. So this is something you'd back in year 8. So 4x plus 10. What's highest common factor? 2. What's left? 2 goes in 2. 4 twice with an x. And 2 goes into 10 5 times. You can always check your answer by expanding it backwards. Now, if ever something leads with a negative, so what's the highest common factor of 6 and 18? Well, that is 6, but because it leads with a negative, we must take the negative out. Actually, I'm just going to put an x in there. We can also see that 1x is common to both. Alright, negative 6 into negative 6 goes once, x goes in x squared x times. Negative 6 into positive 18 goes negative 3 times, and x into x goes once, so we don't write anything. And just to confirm, when we expand our brackets, negative 6 times negative 3 will get us positive 18. So when we take a negative out the front, it's going to change the sign in the middle. It was positive, it's now negative. Okay, now that's pretty simple factorising. Now we get into the harder ones like the trinomials. So first up, we're going to do it by grouping in pairs. So this is when you have 4 terms. So for example, x squared plus 5x plus 5xy plus 25y. So we're going to factorise in pairs. So we're going to factorise this, highest common factor. It gives us x. What's left? x plus 5. Highest common of those two is 5 goes into both and y goes into both. What's left? Left with an x, and 5 into 25 goes 5 times. Now when we see this, we can actually see that in that expression there, there's a common factor of those brackets, which is a common x plus 5. And when we bring a common out, we're left with brackets. What's left? Well, whatever's in front, x, plus whatever's in front. And if we were to expand that, we would end up with our original question. Okay, so normally when we factorise in pairs, you should always end up with a common bracket, which you can take out the front. Now, you just got to be careful again with negatives. If there's a negative in here, you'll have to do it like this one here. Take it out, which will change the sign in the middle. Okay, now factorising trinomials, which are much harder. Now we saw when we did trinomials are 3 terms, and they're the result of binomial expressions. Now, we saw that when we expanded binomial expression, we ended up getting x squared plus 5x plus 4x, which end up getting us 9x, and then plus 20. Now, to factorise, we're going to go backwards. So this is always the hint. This number here was the result of timesing these two numbers together. And this number here was the result of adding those two numbers. So when we go backwards, we're looking at two numbers that times together give us 20 and add together to give us 9. Now I'll give you a few hints on this one. Alright, so there's 4 different trinomial factorising that we need to do in this case. Okay, so x squared plus 7x plus 12 equals. Now, this is where everything's positive. Okay, we always have to look for simple factorising first. Any common factors? No, there's not. So therefore, with a trinomial, we're going to create 2 brackets. Now, because there's x squared, we need to put x and x. Alright, so give me 2 numbers that times together to give you 12. And this is the hint. That sign there can always help you with the next step. Give me 2 numbers that times together to 12 and add together to give you 7. So 3 and 4 is the products of 12, factors of 12, sorry, and they add together to give us 7. So positive 3 and positive 4. Alright, the next one is when this term is negative and this term is positive. And we get 16. Okay, again, start with x times x gives you x squared. Now give me 2 numbers that times together to give you 16 and add together to give you 10. Just ignore the sign here for a minute. Ignore that. So 2 numbers that times together is 16, or 16 and 1 won't give you 10. 8 and 2 will give you 10. So I'm going to do 8 and 2. Now, because this sign is positive and this is negative, well, to get positive when you times 2 numbers, they either have to both be positive or both be negative. And we can see there, they're going to be both negative, because negative 8 minus 2 is negative 10. So there's 2 variations. Now the next variation might be something like, okay, 2 brackets. So we need 2 numbers that times together to give you 10. Sorry, we're going to start with x and x. 2 numbers that times together give you 10. But this time, the we're going to subtract to give us 3. Okay, we said that number, that sign there was a good hint. Alright, so two numbers that times together give you 10 and subtract to give you 3. And those two numbers are 5 and 2. Now because that is negative 10, both my 5 and my 2 need to be different signs, because a negative times a positive gives me a negative. Now what we do, we look at positive 3. So is it minus 5 plus 2? Will that get me positive 3? Or is it positive 5 and negative 2? Will that give me positive 3? Yes, it will. Now the way to remember this is, if it's positive 3, the bigger number of your 2 will be positive, which is 5. So positive 5, negative 2. And my last scenario, alright, so start with x and x. Alright, give me two numbers that times together to give you 12 and subtract to give me 1x. Alright, so two numbers, 6 and 2 won't give me 1, 3 and 4 will give me 1, so 3 and 4. Now, because it is negative 12, my signs have to be different. So, if it is minus 3, positive 4, if I add those together, I get positive 1, not negative 1. So I need to change my sign. So I'm going to get positive 3 and negative 4. Or the trick is, if that is minus, the bigger number will be minus. So again, if that's positive, the bigger number will be positive. If that's negative, the bigger number will be negative. Now at the last bits of factorising, you've got the difference of two squares and perfect squares. Now, difference of two squares, we said, looked like that. Now, it's basically, again, two brackets. Now, if you recognise this as a difference, so minus, and the two numbers are square numbers, all you have to do is square root the first and put it in both, square root the second and put it in them both, and put a plus and a minus in between. It does not matter which way you do it. Okay, so for example, x squared minus 25, it's a difference of two squares. Square root the first, x, so that goes in the front of both brackets, square root the second, 5, and it must have a plus and a minus in between. Now, it can be done by trinomial, so for example, x squared. Now, there's no x's, so what I'm going to do, I'm just going to call it plus 0x minus 25. And we do the same thing, and you say, give me two numbers that times together give you 25, and subtract to give me 0. So they've got to give you 0, they've got to be the same number, so 5 and 5, and they've got to be opposite signs because it's negative 25. Okay, so if you can remember the rule, it's much quicker, but it can be done by a trinomial. Now, a perfect square, so x squared plus 8x plus 16. Now again, that can be done by using a trinomial. Give me two numbers that times together give you 16, and add together give you 8. So, 4 and 4, and they're both positive, which can be written as x plus 4 all squared. So that's easy for that one. Now, the problem with perfect squares when it's not 1x squared, so for example, 4x squared plus 12x plus 9. Again, we look for simple factorising, which doesn't occur here. Okay, so always look for a perfect square. In a perfect square, is the result of square root and square root, and see if it works out. So square root of 4x squared is 2x, square root of 9 is positive 3, or negative 3, but because that's positive, we'll leave it as positive now. So that becomes 2x plus 3 all squared. Let's just check it out by doing, okay, the middle bit should be double the product. So that gets you 6x, double it, gets you 12x, so it's good to go. I hope that helps. Just keep on looking at this video and let me know if there's other things.